Good afternoon. My name is Jay Kramer. I'm president of Network Storage Advisors, a marketing consulting firm in the storage industry, and I'm one of the people who was one of the founders of the event 10 years ago, and it's wonderful to see how this has grown. It's truly a pleasure to introduce our next speaker. It's a very small world in the storage industry, and as I've known this speaker for over a decade, when he was with a very successful startup that was acquired by Cisco, and now successfully leading one of the fastest growing hybrid and all-flash array storage companies in Tegile. Our topic is a very exciting one today for our industry. Which is the right path, hybrid or all-flash arrays? And I'd like to turn things over to the CEO, co-founder at Tegile, Rohit.
Well, good afternoon, everybody. And thank you, Jay. Really appreciate it. So I hear these are the diehards. Day 3, we're still at it. We're making flash happen. We're going to make it a flash data center, right? Okay, so of course the question came up, flash or hybrid, and I'll get to that in a little bit. But before we get to that, the biggest aspect is we build these systems. And as we build these systems, is there a methodology here, or is there a purpose for them? And what are we really going to be doing with these systems? Can we fundamentally change the way business is really happening? And so if we can focus on that part first, I'll come back, of course, to the technology that enables that business in every way. Okay. So you've heard flash at least 1,000 times, maybe 1,000,000 times over the last 3 days. Have I got a news flash for you? Okay. When we look at the Fortune 500, in this decade itself, we will see 40% go away. Okay. That's almost 200 companies of the Fortune 500. That will no longer be allowed at the end of the decade. And the reason for that is simply that the rate of change is increasing very, very fast. And yes, we've always said there's a rate of change in business, but things like flash allow you to change that rate even faster. Okay? If you all remember, there was a company called Kodak. Okay? Extremely well, profitable, 2 billion and plus in market cap, 28 billion plus in market cap, almost 140,000 employees. In 1975, they invented the digital camera. About 4 years later, the team that invented the digital camera took it to the board. It was about yay big. It did 0.01 megapixels. Okay? And the response they got from the board was, we're in the business of quality pictures. When we produce a picture, it is 87 million megapixels. Okay. We print paper, we do chemicals. This is a toy, forget about this project. Okay. Many years later, in 2012, that company goes bankrupt, specifically from the digital camera itself. And as we look at the next wave, really, of companies, in that same period in 2012, we get another company which starts a photo sharing application, okay? And that's Instagram. And 13 people are able to generate $1 billion in market cap because they could reach the world, and we can now reach the world much faster with that rate of change. I'm going to tell you that storage is going through exactly that same change rate. Okay? When we look at the existing incumbents that provide you storage, they are not looking at it fundamentally different. They're looking at the architectures in exactly the same way that we looked at them 2 decades back. It is no longer a disk-based infrastructure. It is a flash-based infrastructure. It is a persistent memory-based infrastructure. It's a PCIe-based architecture. It's a NVMe-based architecture. This curve of speed will continue to change for us. We are finally, with disk and storage, at the capacity of Moore's law or beyond Moore's law. And storage has been holding us back before that. So with that change in data, what can we really do with it? If you look at it from that perspective, a rock mover now collects about 2.4 terabytes a minute for decision making. That's a lot of information. Can we collect that rate of data and store it on a disk? Will we have to build lots and lots of data centers, even more than we did before, if we continued in that disk infrastructure? Disk is gone. It is now a flash world. It is our job to really create the migration path into a flash data center. We can continue this and look at it across the board. Today, the Internet of Things has created 12 billion appliances that are connected. Okay? By the end of the decade, this 12 billion becomes 50 billion. And it has 1 trillion sensors attached to it. That's about 403 zettabytes of data a year. The rate of change is here. Let's adapt to it, and let's put architectures in place that can absolutely make that happen. Okay? While you were driving here or flying here, the 787 is now starting to move into motion. We're starting to see a path where people are collecting data for analytics and decision making on a constant basis. The 787 collects 40 terabytes an hour of data. Okay? 40 terabytes per hour, per 787. While you were all traveling here, there was about 1,500 birds out there. Just multiply those numbers. Data collection is changing. We have to adapt to it. Okay? Let's take a slightly different example. In the dark ages, about 4 years back, you had Pandora. Pandora was the one that started the music service industry. Okay? And as they started the music service industry, algorithmically, they were able to tune your likes and dislikes. Well, they're yesterday's news. And the reason they're yesterday's news is because Spotify and Apple are now collecting more and more data and can take that data and tune it much better to your listening habits on a minute-by-minute basis. Data will make decisions in a different way, and all technologies as they come in will need that data collection. Google has already proved out the car without a driver. In that motion, we are collecting data on a constant basis. And what does that mean for your children and my children? It means that our teenagers may no longer need to learn to drive anymore. Okay? Our freeways, yes, believe me, we would all sleep a little better, right? Okay. If you look at it really from that aspect, they will not need as many freeways. We will run faster on those freeways. All that will happen through data collections. You add Uber on top of that, and you've now got yourself an on-demand engine. In that on-demand engine, you can ask for an SUV when you want to pick up the children or go for a hike. On the other hand, you can ask for the Ferrari when you want to go for a date. Okay? This future is not too far away. We're already putting the fundamental foundation for that in place today. Okay? And with that, really, I would say, what's your mean time to wait? Okay? How impatient are you going to continue to be? How impatient are your systems going to be? How are we going to satisfy your drive to go get a car as quickly as possible? How quickly are we going to be able to do this from a disk-based methodology versus a flash or a memory-based methodology? So we believe that the storage is holding us back. In this motion of holding us back, we really need to think of an architecture fundamentally from the very beginning itself. Okay? And I'm going to talk about a few customers that Tegile has, and their storage was really holding them back. Before we got there, we had a prospect called Pine River Capital. They're about a $20 billion hedge fund. In this motion, they were closing New York and trying to open Hong Kong. It was taking them 22 hours to run their algorithms and analytics, and there was not enough sufficient time for Hong Kong to really make any decisions at all. Okay? It was fundamentally affecting their profitability. In this motion, we were able to run their systems in an all-flash environment. We now went from 22 hours, okay, down to 4 hours of processing time, providing the business back 18 hours to really run those algorithms over and over again, to compute as liked and really change that motion. Okay. The current incumbent infrastructure was also about 540 terabytes. Okay. So it was taking a large part off the data center. A half a petabyte, not too long back, 4 years back, took almost 1,000 square foot. Okay. When we look at that motion today, the data reduction technologies such as deduplication and compression have taken Pine River systems and brought them down to 240 terabytes. Okay? That's almost a 50% reduction in data in what you hold today. CPUs are faster, processing is faster. Why are our architectures still old architectures to support that? Okay? When we take this and go one step further and really focus this on other environments, okay? The hedge fund, you might say, is somebody who needs business on an everyday basis, is the top end of the spectrum, and so therefore will spend dollars to really make it happen. Well, here's another one. It's a high school district. It's called the Brighton School District in Colorado. They were running, or actually trying to run, 1,000 users in a virtual desktop environment. When they were running this in a 1,000 desktop virtual environment on an existing incumbent storage environment, they were seeing 18 minutes of boot time. Okay? Imagine the mayhem in your children's schools when it takes the teacher 18 minutes to boot up her system and they are unable to study at the beginning of every day when they're trying to make this happen. Okay? So it is across the board, whether it is a hedge fund or whether it's a high school district. In this case, on a Friday night, we moved new hybrid-based systems into place. And when we did that, on Monday morning, that 18-minute boot time went down to 14 seconds. Okay? That is a fundamental factor change in how we will proceed forward with information technology. Okay? And the storage has been holding us back. Okay? This was the vision that we had about 5 years back, in about 2010, when we started down the path, really, of a fundamental, from the ground up redesign of systems. Okay? And we felt that, yes, the flash architecture was going to be here, and we felt there would be always a medium beyond flash. We had 7,200 RPM disks, and we had 15,000 RPM disks, and we had tape. So that motion doesn't change. The rate of change has become faster. And so now we, of course, have flash. In that category, we have dense flash. We have fast flash. And Micron Intel this morning talked about cross-point, which is really at the next level of this with persistent memory. There will always be a faster layer. There will always be a capacity layer. The faster layer will be more expensive. The capacity layer will be more economical. There has to be a balance and an architecture that defines that from the ground up. So when we look back and we said, how do we design a storage architecture if we had a fresh drawing board? And our motion was, let's take the best of what the incumbents already have today. That was, of course, data reliability. Data reliability was fairly fundamental. You started and did everything in that data reliability. We took 2 years to make sure that every system was extremely, extremely reliable. On top of that, we also felt that putting a foundation in place right from the very beginning would give you a motion of change later on that would be less problematic to our customer base. And so we took a unified protocol, and in this next generation of players, we're the only ones that give you iSCSI, Fiber Channel, NFS, and SMB. So really, from a user perspective, it's really about the flexibility of the system, and a multi-protocol architecture is a choice that you make based on the applications that you run. Okay? In this same motion, we also feel that you should be able to have one operating environment. The question is not flash or hybrid. It is a question of how do we make sure that we can run every application in your environment. So in today's motion, when you have something extremely fast, we call that a all-flash system. Okay? When you have something that requires performance and balance, what we really need in that motion is really an architecture that says, I can run out of cache, and as I run out of cache, what I'm able to do is service 90 to 95% from that cache while storing the data really in a capacity layer, which is disk itself. Okay? So in every way, it is one flash platform, any operating in one single operating environment, and any workload. In this workload, you may have a transaction processing system, just like the ones we talked about earlier that need instantaneous response. When they need the instantaneous response, they run in the all-flash environment. And when you have other applications, such as messaging applications, they need to run really in a messaging environment, needs to run really in a hybrid environment itself. Okay? This doesn't change as the architecture changes. Okay? We're already starting to see dense flash and fast flash. So to us, in that motion, when your fastest application needs to run, it can run now in the next generation, which is not more than 3 or 4 months away, in a full PCIe-based all-flash environment. Okay? You can still take that PCIe-based flash and break the cost and capacity of it with dense flash. Today, Tegile uses 2 terabyte systems, 2 terabyte hard drives in their systems. Moving those to 4 terabytes and 8 terabytes is not too far away. Okay? So as we do that, and as we're doubling the density, we're of course slowing down that flash. Beyond that is 3D as well, and that will also increase that rate of change. So in this motion, when we look at it, about 5 years back, the cost of flash was 25 times the cost of disk. Today, that cost is about 8 times. And we're told by our partners such as Western Digital, as well as SanDisk, that we're at a curve where we'll be about 2 to 3 times faster in this motion. So as we get faster, there are a number of applications that are dying to run faster. The more data we collect, and as we collect it, we need to respond quicker. Forget about other systems. We collect the data on a constant basis for all the arrays that are out there in the marketplace. Those arrays provide us the information to tell you when you're running out of performance, when you're running out of capacity, and how we can pre-act to make your life better. This is the way the entire IT industry is going. And as we do that, what we will be able to do is really break that curve on a constant basis with the fastest layer as well as with the capacity layer. So going back to the main point that everybody has been debating, is it a hybrid world? Is it an all-flash world? It is an and world. It is an all-flash world and a hybrid world. And in this motion of all-flash and hybrid, it is truly about your workload. It is the workload that is going to make a large part of the difference on how much money you're willing to spend for that workload, as well as the capacity. In this same motion, we had another customer as a prospect. I'll just call them the burrito guys. And when I talk about the burrito guys, they said that they needed to run an environment where they had to make their applications faster on the database side so that they could supply the chicken at the right time and supply the guacamole at the right time as well, right? in this motion of providing it at the right time, they needed, like Pine River Capital, to increase the speed of their applications, specifically on the database side. When they did that, the two vendors came back and said, well, here is your all-flash experience, where you can run these systems in all-flash. And the answer back from them was, we don't have as much money to run an all-flash system. Okay? And so one approach that one of the vendors took was to say, well, over time, over TCO, it's really going to be about, in this 5-year period, flash is going to be more economical for you. The answer back was, we don't have the budget to make this happen. The approach we took instead was, we took their fastest applications, ran them in all flash. The remaining applications, we just added a hard disk shelf to the all flash controller. And we also took a disaster recovery approach of taking that environment and replicating it into a hybrid environment. In this motion, we were able to give that organization a method to run their applications faster in all flash. In the hybrid model, we were also able to make things run much faster, but we were able to do it in an economical manner, as well as future-proof the customer, so that in their journey to all flash, this was a process where they could start in this method and then over time move over to flash. And subsequently, of course, they've increased their flash within their data center as well. And so to us, it's really at that time, at that juncture, how we make it happen is based on the performance of the application requirement, the capacity requirement, and of course, cost plays a huge factor in this every day. Okay, as we go into the future, the next aspect to us really is, from a 50,000 IOP box, how do we provide an environment that can go into a 5 million IOP environment as well? On the other side, how do we make sure that from a capacity perspective, that we're able to provide this in an architecture that will go from 10 terabytes to 20 terabytes, all the way into 10 petabytes. And so we're really focused on that architecture in this model, really, to take it into saying, it is your data center, and how do we take this data center and migrate it into all flash? Okay? In the same motion, you will see from us, how many people coming to VMworld? Okay, a few people coming to VMworld. If you're at VMworld, we will show you the next path in our journey, where we feel we can take you more towards the 10 petabyte environment in a small half rack environment. Okay, so we talked about density increasing. Density between last year and this year in this motion will increase 50 times in 1 year. Okay, so it's a fundamental shift. We will no longer need a large data center, and let Tegile show you that specifically in that manner. Okay, as we look at this as the next stage, we're also looking at additional technologies that will make the engine faster as well. The density curve makes it more economical, makes it more compact, but on the other hand, also makes it extremely economical because of that density. But it loses its speed, and as it loses its speed, you need the next generation of fast flash, and so with that, you will also see PCIe, NVMe, as well as persistent memory as the next step itself. Okay? To us, the flash revolution is just beginning. We feel the transformation of the data center will take the next 3 to 5 years to move all the performance applications really into an all-flash environment. Okay. With that, I'd like to actually open up for questions that you may have, specifically on the technologies or on the directions that you all are seeing across the board over the last 3 days. Yes, sir.
Hyperscale, can you comment on hyperscale?
Yeah. Hyperscale as a market tends to be a market that's very specific. Let's break up, actually, let's segment the market for you a little bit. When we segment the market, you've got the SMB, you've got the mid-range of the enterprise, you've got the large enterprise, and then, of course, you've got the hyperscale. Okay. When we take it and distribute it across these 4 areas, what we generally see is the appliances we're talking about are really for the enterprise as well as for the mid-range itself. Okay. To us, these systems require a lot of software, and as they require software, they require a SAN NAS environment. What we tend to see in the hyperscale environments are those are more software-defined architectures for a single purpose, whether it is a genome application or whether it is fast processing for X, Y, or Z. In that motion, not a space where Tegile specifically focuses. It's a long-term, and it takes 2 to 3 years to build a good system in a HPC environment specifically. We do not see as much flash today in the HPC environment simply because an overall cost structure for HPC still tends to be low. Smaller number of systems, not as many vendors in that marketplace, and because of that, the technology innovation for doing it for one specific customer becomes more a consulting as well as technology innovation project versus a repeat model, which you will see in the mid-range of the enterprise or the enterprise itself. Yes, sir.
What's your thought process about the in-memory storage?
Okay. To us, in-memory storage is the next generation, really taking flash to the next level itself. And so if you define an architecture with speed and with capacity, in that motion to us, the in-memory can run your fastest applications. And now that you have persistence in that model, without persistence, you cannot provide a database environment or a transaction environment that gives you data guarantee. As long as you give us persistence in memory, then we can treat it as the same medium as we did disk or any medium that took a long-term storage motion. So to us, it is a point in evolution. Okay? As you make, and Intel specifically makes, that persistent memory more economical, you will see more and more become the top layer of that portion, and we will see our fastest applications run there itself. The way to break the back of that cost structure while we're moving in that direction is exactly in the same way as we've done it for flash and disk. So in this motion, flash becomes the cheaper capacity layer, okay? And the persistent memory becomes your cache engine itself. In that cache engine, as we look at it, you will be able to do 90 to 95% of your work in the cache engine while using only about 1/10 of the entire size of the disk infrastructure. Today, when we do subsystems, it takes us about 400 terabytes of flash to optimize about 20 terabytes of hard drive. Okay? So to us, that formula continues in the model as long as you're okay with a latency level that is not consistent but is still highly performant. If you need a low latency environment, which is guaranteed, then you must run your application in the fastest layer, which would be persistent memory itself. Yes, sir. The question is, when we are a Wall Street environment, which requires trading in an instant, how do we make sure that we're running only in the flash, the fastest portion? Whatever your process might be, right? If it is a regulatory compliance, you're looking at it 2 aspects. The speed of responding or reporting is one aspect of it. The second aspect may be security, and does the system itself provide you security? Security is a general motion today. Most of our systems for all vendors today are encrypted, and you can encrypt the information. So it's not about the security aspect of it, it's about the speed and handling the speed. So let's take that example we talked about earlier on Pine River. In Pine River's case, yes, the trading application absolutely required an instantaneous response, and so therefore, it runs in the all-flash portion of the array. What does that mean? A CPU controller box, which has dual controllers, of course, and as it has dual controllers, it's also running the flash subsystem to satisfy every aspect of that latency. In this environment, you can guarantee a sub-millisecond response. Okay? When you take their other applications, okay? Other applications may be long-term compute that do not need to respond as quickly as they can. In that motion, you can run in a hybrid environment, and what that means is an all-flash head accelerating the hard drives that are sitting on the system. And when you do that, what you're able to do is you're able to guarantee a sub 2 millisecond response in the motion. Okay? So it's about your workload, and when we look at it in the workload, we can run it in the fast portion or in a more balanced portion, which becomes the hybrid. Now, what I'll also say is it's not just Wall Street that requires the speed. Okay? Everybody requires speed. We just talked about a school environment, a district itself. The district asked for much faster response for their kids so that their desktops could pop up faster. So to us, it's about any application. Okay? It generally tends to be databases, virtual desktops today, but as we continue to make more decision making, we'll continue to see that forward. I'm being told to get off the stage. Thank you very much for your time.
Thank you very much, Rohit. Appreciate it.